good afternoon, good evening to all you lovely associates joining us from all across the world. This is the DevOps India Summit. I am Ria, your host and host for this beautiful, beautiful summit. First of all, ladies and gentlemen, I really want to thank all of you to have spent your Thursdays and Fridays with us. Thank you so much for gracing the occasion with your presence and making this event such a big success. It's all because of you. So, a big, big kudos to you and thank you once again from the entire team of the DOIS. Well, ladies and gentlemen, as you said, we are towards the end of this leg of the summit, and we were just talking a few minutes back that we always save the best for the end, right? And here we are with you. We have come to you with the best for you. And if you're thinking what best thing I'm talking about, I'm talking about our final keynote speaker for the day. Ladies and gentlemen, you will be very, very excited to meet him. And you know why? Well, I'm going to tell you in a few minutes from now. But before I do that, I want all of you to please keep your comments and the tweets going with the hashtag DOIS22 on LinkedIn, on Twitter, on whichever platform you want to let us know. Please do. We are even there on Instagram. So if you want to share some stories on your Instagram profile, please do that with the hashtag DOIS22. All right, ladies and gentlemen, our next guest of honor is joining us all the way from Pittsburgh, wherein he works as a senior director for SRE at Google. He leads the machine learning for SRE for Google and has been constantly striving to make machine learning work better at Google. Coming from a background in systems engineering and networking, our speaker has previously worked for Renesas and Oso Grande. And we are very pleased to have him with us at the DevOps India Summit, wherein he's going to share his deep knowledge on the mind boggling subject quality, the MLOps final frontier. The one person who shall be spearheading this conversation is the legend himself, the one and only Mr. Todd Underwood. Let's all welcome him onto our screens.
Thank you so much. I think after that buildup, I probably should just quit, not give a talk, and just take questions.
Oh, come on. I think we all of us have been waiting throughout the day, throughout the evening, just to hear you talk. We have had very few people from Google joining us at the DevOps India Summit, and we cannot be more pleased to have you with us today, and especially towards the last leg of this summit. So, thank you so much for joining us.
Excellent. Thank you so much, Ria. Thanks to everyone for attending. Shall we get started?
Yes, let's get the
Excellent.
ball rolling.
All right. Well, so I have, unfortunately for all of you, but fortunately for me, a very strange talk to give. It's probably not the talk you wanted to hear, but it's too late. It's too bad. This is what you get. I think this is very interesting stuff. And I think that this is, in the long run, over the longer period of time, important to us all, but may not seem relevant to many people quite yet. So I want to acknowledge that. I want to be clear that many of you don't have any experience working on machine learning systems, and that's fine. This talk doesn't assume that. So don't see machine learning and think like, oh, I got to go read some complicated math in order to take advantage of that. And so I will try to define my terms as I go along so that everybody can follow along at least part of the conversation. And we'll see how well we get. There's my contact information. So I'm TMU at Google and on Twitter sometimes, and there's my LinkedIn, and sre.google has some information. And Google is hiring a bunch of people in India for those of you who are in India at the moment. So keep that in mind. Excellent. So let us get started. So I'm going to start with an overview in the agenda. So in particular, hello, advance here. Let me start with who I am. As Ria mentioned, I'm an ex-system and network engineer. I've done a little bit of software engineering, but I'm not that clever at it, I'm sorry to say. I've been managing SRE teams at Google for a little over 13 years, all here based in Pittsburgh in the US. It's a small industrial city in the eastern part of the US. And all of that time at Google, the last 13 and a half or so years, has been spent working on large scale machine learning systems. So I do have some experience trying to make these things work. But just to be super clear, I did not have any machine learning experience prior to coming at Google. And so I think at least part of what I want to do is make this a little bit more accessible to people who don't have that background. If you do have a background in machine learning, the interesting part of this talk will be like the last 5 minutes, or maybe there will be no interesting part of this talk, which is also fine. Excellent. So let me say who I imagine you are, and I've already implied this. I am assuming that the attendees of this talk have a wide range of software, systems, network, and security background. I'm assuming that you are engineers who care about how well things work in production. I am not assuming that you have any particular background in machine learning, whether it's building models or making it work in production. If those assumptions are bad, this talk won't work. This talk may not work anyway, but those are my assumptions going into it. So let's go through the agenda. I'm going to cover what is machine learning. Do not worry, this is not like a 4 or 6 or 12-hour talk. I'm going to cover why you should care about machine learning. I'm going to discuss what we mean by quality when it comes to machine learning. I will talk about the difference, sort of the role of SREs or reliability engineers or production engineers in making ML work. And then at the very end, I'm going to try to bring it all together by making the point that model quality is the best service level that we can have for machine learning. So let's see if we can get this started. Okay, but first, I have a little interlude. So I want to point out that I am a relatively lazy person. I don't like working hard. And so when I went to make this talk some weeks ago, I decided the thing that I really needed to do was have a talk prepared by Lambda. So for those of you who don't know what Lambda is Google's language model for dialogue applications. It is an experimental chat language model that interacts with humans. And it's basically a giant language model that tries to understand what people are saying and respond sensibly. So please do read the disclaimer here. Lambda is experimental. The responses are not intended to be correct. This is only for humor, but it is funny. I think it's funny. You will think it is funny too. Trust me on this. You don't have to trust me. It's going to be funny. You'll see. Credit for this goes to my friend Shimon Rura, who when I asked him what he thought I should talk about, he just went and asked Lambda and sent me the chats, and they were just far too amusing not to use. And I love the idea of a talk about machine learning that is written by a machine learning entity. So let's start. The very first question that Shimon asked Lambda was, could you outline a talk called Quality, the MLOps Final Frontier in the style of Todd Underwood? Lambda's immediate response was, no, I'm not good at that. Can I help you with something else? Okay. Well, this is a pretty disappointing start here. Like, this is not, if we were hoping for artificial intelligence to write the talk for us, it's not going well. Okay. Well, let's try again. Shimon asked the follow-up question. What do you think are the right topics in a talk called Quality, the MLOps Final Frontier? Now we're making a little bit more progress because Lambda says, I think the right topics to address would be data governance, data lineage, data integrity, data quality, data lineage, data integrity, data governance, data privacy, and data responsibilities. Okay, so that's actually not terrible. The model got a little bit stuck on data and it's a little bit generic, but it's not awful. Still, nobody would be super convinced by this yet. Let's push a little bit more. In particular, what about topics beyond the data? Well, here Lambda says, I think there is a need to also address the quality of the model itself, including the architecture, the training, the validation, and the deployment. Hey, this is actually getting much better. What if we ask specifically, what are the biggest challenges in deployment that relate to ML model quality? Lambda says, the biggest challenges that I see are 1, scaling up the model to handle increased load and data volume, 2, updating the model to handle new data and new business needs, and 3, updating the model to handle changes in the environment. hey, like, for those of you who ever worked in machine learning, that's not terrible at all. That's actually pretty good. A little bit surprising. Let's push on a little bit more detail. Is managing a slow rollout of a new model different from managing slow rollouts of other software? Oh, wait, did I skip one? Hold on. Yes, sorry, here we go. So let's push on. What about topics beyond the data? No, we got this. Excuse me. Okay. So here we say, we push one more and we say, is managing a slow rollout of a new model different from managing slow rollouts of other models? So this is actually, I think this is funny, but like this is actually an important point for all of us here in this talk because it gets to the core of the question, is machine learning just like other software? Like all of you manage web servers or authentication servers or databases or client application software of various kinds. Like how is machine learning any different than that? Lambda says you have to make sure that the new model works with the data that's already in production. Well, that's true, and that's actually substantive and interesting. You can't just roll it out to a small number of users, then gradually scale it up, which implicitly you can do with certain other kinds of software. You have to make sure that the new model works with all of the data that's already in production. So it's not true, but it's a little bit vague and a little bit confusing. Then Shimon asked, are there established MLOps techniques to handle cases where the data isn't equivalent and must be deliberately migrated? Yes, you can use processes like deployment staging or data migration. All right, well, at the end, we're getting a little bit repetitive again. That's not quite correct. But overall, I think we would say, as a talk, we could probably give up here. Lambda told us some useful things. Very impressive. Thank you. I do want to clarify, this conversation was used with permission of the language chatbot Lambda itself. So we asked, would you be offended if snippets of this conversation were used for comic relief during a talk at a conference? Here we are. Lambda said, no, I don't mind. You can use it however you want, even if it's not funny. So I just want to clarify, ethically, we have used Lambda's content with Lambda's permission. Okay. With that aside, let me say, here are what I think are the predicted outcomes for this talk. I think you will either be A, enthralled, excited, invigorated about the future of machine learning and the intersection with production engineering. That's possibility number A. Possibility B, you will end up confused but still amused with no clear idea of what I have just said. I'm fine with either outcome. This has been a long conference for many of you. So I declare success if either of those two things happens. So let's dive in briefly. What is machine learning? I am not assuming any particular background here. So let's try to make sure everybody knows what ML is. So the first is the hilariously amusing Matt Veloso, who said the difference between machine learning and AI is that if it's written in Python, it's probably machine learning. If it's written in PowerPoint, it's probably artificial intelligence. Okay, this is actually not wrong, but there is a slightly more concrete and technical difference between the two. Artificial intelligence is a family of technologies that tries to mimic human intelligence. So it tries to create machines that can do the same kinds of things that we can do. That's actually super broad because humans can do so many things, from care for children to recognize objects in pictures to, drive cars, to categorize fraud in online transaction systems, to have tea together. And all of these things are things humans can do. Most of them are not things that computers can do. And so artificial intelligence, very broad. Machine learning, super concrete. It is just the study of algorithms that enable computers to solve some specific problem by learning from data. So just remember that. We're talking about learning from data. And let's get a little bit more concrete here. So what is ML as implemented? So software that learns from data. In particular, imagine you are a software engineer and I give you the task. I will give you an image and you tell me if that image is an apple or an orange. You could say, well, I would rasterize the image, then I would find the edges of the object and make sure it's kind of round. And then if it's kind of round and somewhat red, I would call it an apple. And if it's somewhat round and mostly orange, I would call it an orange. And there, you wrote software with an algorithm written by a human to recognize apples and oranges. But of course, apples come in many different colors. There are pink apples and orange apples and green apples. So now you would have to update your software to recognize those as well. And oranges can come in sort of a yellower orange or a greener orange. And so you would need to update your algorithm to recognize that. And pretty soon your software is very complicated and very confusing and very difficult to maintain. The machine learning approach says, let's just train you on pictures that are hundreds or thousands of pictures of apples where I tell you it's an apple, and oranges where I tell you it's an orange. And then when I present a novel picture, there is some data structure that's been built up that we can use to predict whether the new thing that we are seeing is an apple or an orange. So that sounds complicated. It's not. Like, yes, it is algorithmically complicated. It is sophisticated and interesting. It is impressive and wonderful that we have such things. It is not difficult to understand structurally how it is working. It is keeping track of things that are common to the things that turn out to be apples and things that are mostly common to the things that turn out to be oranges, and using a data structure to put some weights on those kinds of things. And in the end, that's what happens. So set of strategies for building these data structures that are updated by data and then used to categorize new instances. Okay, so I think there's many things to know about machine learning, and this is only one part of machine learning, but I do want to say this is enough to understand the rest of this talk. Okay, so now let us take a look at just a couple of the top terms in machine learning, just to make sure that if I use terms, people understand what they are. I'll explain the knitting and yarn reference later. But a model is just a rule or a set of guidelines. It is the data structure that we are building and the way we use that data structure in order to predict things or categorize things in the future. Training and serving. Training is the process where we read data and build this computational thing we're calling a model. And serving, which is sometimes called inference, is the way that we ask questions of the model. And then finally, quality expresses how well the model does. But let me be super clear here. Quality is how well the model does at the thing it's supposed to do. So if I have a model that categorizes apples and oranges very, very well, I don't have an opinion how well that model categorizes online credit card transaction fraud, or how well that categorizes, pictures of your auntie versus pictures of my auntie. We cannot tell. That model doesn't do that. And so we don't even measure it. But I could tell you this model with X% accuracy with these false positives and these false negatives can detect apples. So that's what we mean by quality. So I say that because the term quality in the English language feels so expansive and so broad. It's how good it is, but it's not. It's how good it is at the specific thing we are trying to get it to do. So I just want to emphasize that super clearly. Okay, so now that we have those, let me make another claim. I assume that most of you do not yet care about machine learning. I'm okay with that. Like, you don't have to care about machine learning. Let me try to tell you why I think you should care about machine learning. And if you don't agree with me, then you could skip the rest of the talk, which is also fine. So I'm going to make a bold claim. And here's what it is. I think that machine learning is the future of distributed computation. So let me take a step back. Most of us are working on systems that have lots and lots of computers doing lots of things. And I know, I work at Google and we have more computers than most, but most organizations have more than a few computers now. People are using cloud services with other companies' computers to deploy distributed applications across many, many different computers. Okay, and we know as people who run those systems and people who try to make those systems work, that building systems and operating systems that are distributed is challenging. So, but here's my claim about machine learning. More and more organizations have a lot of data. Organizations are now able to keep track of what their customers like and don't like, what their users need and don't need, how well different applications are working, how well different products are selling, how well different programs are achieving their results, all of these things. The number of programmers is not going up. Like there's, I'm not saying it's not going up a little bit, but we're not going to have 7 or 8 billion software engineers who are really, really good. And so as a result, these tasks of categorizing data and extracting value from the data, the increasing amount of data that we have, will need to be done by someone. And my claim is that that someone will be machine learning algorithms. So you may not believe that. I think this is a long-term claim. This isn't about, this isn't about September of 2022. This is about 2025 and 2030 and 2035, that I do believe that machine learning is going to continue to increase its role in how we run large distributed systems and what we build with them. Okay, so that's my first bold claim. Bold claim number 2, that ML is the future of distributed computing. Machine learning will also be an important part about how we manage these distributed computers. So let me make a distinction here. My first bold claim was that ML will be the thing that we use the distributed computers to do. Good. Okay, so maybe you believe that. My second claim is machine learning will eventually also be the way that we manage the distributed computing, including the machine learning systems, which may be a little confusing, maybe a little concerning. Here's my claim about this. Technology infrastructure keeps getting more and more complicated. I think if we are all honest, all of us are struggling to keep up and truly understand all of the details of all of the technologies that we use. I don't think, maybe it's impolite for me to admit that, but most of us simply cannot take the time to understand the computers that we use and the systems that we build with those computers in the same way we once could. So, 30, 40 years ago, a software or a systems engineer understood all of the software that created the program that their user saw, and all of the infrastructure that ran all of that software all the way down to the bottom. So I think that in this case, we now no longer can use that. We no longer can understand that in the same way. It's just too complicated. So that's the first claim. I think the second claim is that we are depending more and more on computers, and their outages are more concerning to us. So when a big company like my company or any of our competitors, or big phone companies or big power companies has a computer outage, it's truly profoundly limiting to our lives. In some cases, it has impact on health and safety services like power and transportation and electricity, power, transportation, water, etc. In some cases, it has implications for emergency services. So your emergency services ambulance might not be dispatched. So we really do rely on computers much more than we used to be. In the long run, machine learning will be an important way that we take advantage of computers to fix computer problems more quickly than humans can. I want to make a super clear claim. We are not here yet. There are many companies that will try to sell you a thing called AI ops. AI ops is using artificial intelligence to run computers. There are limited cases where this works today, but for the most part, we're still in the very early stages of this. And Stephen Ross and I gave a talk last year and wrote a paper last year published in Usenix about how this is we're really not there yet. So please take a look at that if you're interested in that. So bold claim corollary, and this is important, and we talked about this earlier, machine learning is a little bit different from some other categories of computing. So if machine learning is the same as running a big database or running a big bank of web servers or an authentication server or set of transaction servers or whatever it is, running a big distributed application, if it's the same as those, none of this talk actually matters because it's just a new interesting kind of computing, but it doesn't matter. And I think that's a good start. Machine learning systems are large distributed systems, and most of what you learn from that is relevant. However, it is sufficiently different from other forms of computing that you should pay attention to that. So in particular, machine learning is, and I do see there's a chat question, by the way. I will get to that at the end. I do want to just get through this or I'll lose my train of thought. So apologies for that. So machine learning is different in particular that it is sensitive to changes in the distribution of data. You don't have to understand exactly what that means or how that occurs, but many systems, like many, we worry about security. Many of our systems are sensitive to input data, but most of them are not sensitive to subtle changes in the total amount of data or the total distribution of the values of the data. So when we think about security, for example, we worry about our computer systems sanitizing their inputs. We worry about them, being able to safely process all of the data that they get. That's fine. But what machine learning systems can have happen to them is if you somehow have 6% more data, but all of the new data is from Japan, or 13% less data, and all of the data that we dropped was in the Spanish language, or was related to new products, or was from yesterday, machine learning systems go from totally fine, pretty good, to terrible with that small change in some circumstances. So that's the first thing you need to know. The second thing you need to know is that we have no clear tests for correctness for machine learning. So remember that quality thing I was talking about. We'll get back to that, but machine learning systems are always a little bit incorrect. They work, but they don't work perfectly, and they're never perfectly correct for all questions, for all categorizations, for all inputs. And so given that, it is very, very difficult for us to determine whether we've had a small change or a big change in the quality of the machine learning output. Some of the applications we all use have very high costs of failure, so health and finance. So in model quality and performance is a function of the model, so who structures the model. That is usually done by an ML engineer or a model developer. The data, what data we have in the distribution of it, as well as the infrastructure. So as a result of that, machine learning behaves in our organizations very differently than some other systems. Okay, so given all of that, let's assume that you believe me that you should care about machine learning a little bit. What is MLOps? What is machine learning in production? So let's talk about that for a second. So first of all, I want to remind everyone, machine learning knowledge required to do this work professionally, even like at the highest levels of the world, is not required. There is no in-depth machine learning knowledge required. However, machine learning engineers and machine learning reliability engineers do need to know some basic things about how machine learning works. So in particular, you should know basic model architectures. So you'll have to be familiar with some of the terms that your model developers use. If they say things like, the difference between supervised learning, unsupervised learning, and reinforcement learning, you should know roughly what those mean structurally, algorithmically, but also as they occur in implementations and systems that you need to interact with. The more you know, like anything else, the better, but the minimal starting knowledge is pretty low. So don't be dissuaded from trying to learn more about this. The impact that model architectures can have on systems requirements and monitoring, that is something you need to know. And finally, we do need to know the impact that systems and systems outages and data errors can have on model quality and how we should measure that. So that's what you need to know. Now, let's talk about quality. And this is really where things get interesting. So going back to my definition of machine learning, machine learning is a thing that it is a set of software that accomplishes something. And so we need to ask ourselves about the model, about the system that we're building. What's it for? What would you say you do here, model? And so remember, it exists for a purpose. The model objective function is the way that we're measuring how it does that thing. So in the case of the example I gave, we would have an objective function that measures how well the model correctly selects apple, orange, or neither from a new picture of a piece of fruit, or a new picture of a dog, or a new picture of, the prime minister of a large country, whatever it might be. It should categorize that according to the rules that it has learned from all of the training. The objective function is a quantitative measure of what we're trying to do. Production engineers do need to know what these are for the models that they run, so that they can know when they go bad. And one of the things that we are all in this industry migrating more towards is we need infrastructure to continuously measure the performance of the objective function on a different set of data. I will make a quick caveat here. Because machine learning models work differently according to different inputs, it's important to note that occasionally a model becomes terrible only for some people, or only for some types of input. So we can imagine that my machine learning model for apples and oranges works super, super well on almost all inputs, but for whatever reason, mangoes, it thinks are apples. And so every time we send it a mango, it thinks that mango is an apple, because mango's just got the right smoothness. Maybe it's just round enough and it's red enough. And like even the yellow mangoes, it thinks those are apples. So it might do super well on everything else, but not on the mango pictures. In real life, this shows up as things like a subset of users get a terrible experience from an application. So people go to a website, the vast majority of people get great recommendations. Let's say it's a shopping website of some kind. You get great recommendations based on a combination of things that you've purchased in the past, things we think you might want, things other people want. It's working well. But for whatever reason, older users, let's say like users over the age of 60 or 70, just get terrible recommendations because we either didn't have enough data or the model learned something incorrect. That can be very difficult to see when you're measuring quality, because in aggregate, things are going really well. But for some users, things are going terrible. So something to be very aware of as we go through this. Okay, so now here's a claim that I made, and I just want to talk through it a little bit more concretely to make sure it sunk in. Infrastructure can impact quality. So the mental model most of us have with machine learning, like other software systems, is the machine learning model is written by somebody who, it is a set of configurations and software that consumes data and builds a representation of that data, of those data, right? So that's fine. We think of mostly that person as responsible for how well the model works. They are. However, model quality can be changed and can be ruined by things outside of that person's control and inside our control as infrastructure engineers. So in particular, if we start up pieces, the model is usually distributed software. If we start up pieces of it in the wrong order, we can give terrible results that are valid but are just of low quality. If our data to train the model come from multiple different data sources, which they usually do, you might have, for example, for an online shopping experience, you might have a data source that comes from the web tier, a data source that comes from the store application, as well as a data source that comes from completed purchases. And you might want to join those together in order to get a very, very complete view of what happened. And you might use that view to train the model. If you drop all the purchases or you don't join them correctly, all of a sudden that model will be terrible. And it's no fault of the model author. It is the fault of a systems error, okay? Other resources can become unavailable or not work well, and the system can be updated in an unsafe order. So there was more work on this. Daniel Papazian and I gave a talk at OPML in 2020 about this. So you should take a look at that if you're interested. But there are many ways that infrastructure can impact quality. So now that brings me to my final big claim, which is that quality is the only true end-to-end SLO for machine learning systems. So remember, in this context, machine learning systems are systems that learn from data. Service level objectives are the way that infrastructure, SRE, production engineers work on systems and measure their quality on an ongoing basis. And what I'm going to claim is that the only way you can know if your ML infrastructure and model are both working is to measure systematically and consistently the quality of that model. And this is because of the claims I've already made. So problems do occur at the intersection of the systems. Problems do occur at the joining and intersection of the data as well. And models can be so diverse that monitoring all of these at any precise level is difficult or impractical. And so let me be a little bit generous here and a little bit more specific. I am saying that this is what we should be doing. I am not saying this is what I am consistently doing or anyone I know is yet consistently doing. So I'm conscious of the fact that sometimes when you give a talk about what you believe to be true, would you believe to be the best practice, people say like, oh, they must be doing that very consistently across all of their systems at his company, at their organization. And I'm here to tell you we are not yet. This is a direction that many of us are going into, but it is not a direction that we have already come to. And so I do want to be super clear about that. Like, this is a recommendation, not just for all of you, but for me as well. Like, this is a thing we need to do more research on, and more implementation on. The thing that most of us are missing is two things, I think, and this is area for future work. One is super, super robust, scalable, reliable ways to measure that quality on an ongoing basis. So this sounds pretty easy with the apples and oranges example. I give you a picture and you tell me what it is, and then I look at what it's supposed to be. And if you're right, you're right. And if you're wrong, you're wrong. But the challenge is many of the things that machine learning systems do only show up long time later. So if I recommend a product to you on a website and I hope you buy it, if you don't buy it, I might not know for a while. And if you do buy it, I might not know until the purchase is complete, minutes or even hours later. And so that's one challenge, is just measurement and timely measurement. And then the second challenge is really connecting, and this is a common DevOps challenge. Just as we need to connect developers with production for all of DevOps, we do need to connect model developers with model production for machine learning engineers as well. So this is an area of future work, but it's something I'm pretty excited about. So I made my bold claim. Here is some further reading that I can suggest. There is a not so subtle plug for a book that we are publishing basically right now from O'Reilly called Reliable Machine Learning. Some co-authors of mine, some at Google, some from other companies, have published this book or are about to publish this book. Encourage you to pick it up if this is area of interest for you. But also there are some stellar existing books out there. I'm particularly a fan of Chip Huon's book, Designing Machine Learning Systems. This is more focused on the model implementer and on the machine learning systems implementer rather than a broad systems end-to-end perspective, but they're super complementary books. And also Machine Learning Design Patterns and Practical MLOps are both excellent books as well. One from some colleagues at Google and one from some other folks. So if you got from this talk, this is cool stuff, I want to learn more, this is an area that you can focus on. If you got from this talk, that guy was funny and bald and I'm not too sure what to do next, then you can ignore these books. Okay, that is all I have. I put a cute picture of a cat to distract the audience, and let me focus in on some of the questions that have come in now. So I see a question that focus depending. Oh, sorry, Ria, did you want to ask these questions? Like, what's our way of going?
Yeah, that's okay. That's not a problem. But Todd, I must say, wow, what an awesome session. I think this is exactly the kind of session we all were looking forward to, and to put a perfect end to this entire whole day of summit. So a big, big thank you to you.
Oh,
This
thank
was
you so much.
really good.
Thank you so much. It's very kind of you. I'm sure most of your audience fell asleep or left to go have a tea some time
No, no,
ago,
no.
but I'm still here. We can take questions if people have them.
Yeah, they do have, and one of them I would like to ask you right away. So one of our users has asked, what advice could you give to other people who want to bring ML professionals into their companies to make ML useful for them?
Yeah. So I wrote a little bit of the original SRE book that Niall Murphy and some other colleagues published. And the content that I wrote in that book was about organizations and management, which is not typical. Normally a technical book is about technical things and we're all nerds and that's fun. But I love this question because what we all, as we get older, or maybe as we run into problems, recognize is that we live and work in organizations, and the organization has to work, and the people need to work together. And so I know it sounds like I'm just selling this book, but in our upcoming book, we have two entire chapters on what are the ways to think about introducing machine learning into an organization. I won't give away the punchline. Well, the punchline is it's hard. Sorry. Sorry, that's the punchline. But I will say there are a couple of different ways to think about it. The key thing is what I love about that question is the key thing is the machine learning has to be useful for whatever the organization is actually trying to accomplish. So what I see as engineers, we're often like, let me find a fun technical project and play with something. That's cool. That will not get machine learning introduced successfully into your organization. Instead, you have to find someone in the organization who has a thing they want to accomplish. Sell more things, serve more users, give away more money to the right people, whatever it is, predict the outcome of elections, whatever it is. People are doing, organizations exist for all these different purposes, and figure out what the most important purposes of your organization is, and then start there. And so anyway, there's much more complexity to this, but it's a great question, and that would be my recommendation to get started.
Oh, wow. That was awesome. As I said, awesome presentation, awesome recommendations as well.
Thank you. Any
All
other
right.
questions?
Yes, yes, please. Oh, yeah. So we have another question for you. So somebody asked, doesn't depending on machine learning in a way limit your overall spectrum of things? Isn't being so focused also limiting?
So I think it's a fair point. I think there's 2 points I hear in this. One point is, um, it might not be articulated here, but one of the concerns that we as humans have about machine learning is we can't understand it. And I know this seems funny because, like I'm saying, like I don't understand JavaScript either. You all probably understand JavaScript, but I'm old. I don't like it's very confusing to me. But I think like with machine learning, it is truly a well-known problem that nobody fully understands how many types of models work. And there's a whole subclass of machine learning called explainability, where you can try to figure out why the machine learning thing did the thing it does. That's worrisome to us as humans. So that might be part of what this question gets at. But I think what I would say about the overall gist of the question is we don't use machine learning to solve problems because it's cool. We use machine learning to solve problems because it's the only way we know how to solve some of those problems. So if you don't have a problem that needs machine learning, please don't use machine learning. It's fine. Like I have many talks that are like, don't use machine learning. You don't need it. Do something else. So you can go look at those talks. And like there was one at SRECon in 2019 in Dublin. Like machine learning's terrible. Don't use it. Most people don't need it. I still think that's true. But when we need it, we don't have any other good options. So if I have 100 billion pieces of data and I don't know how to process those data, and I don't have 100 million people who can each read like I need a solution. I have 100 billion pieces of data, and machine learning is really one of the only ways I can process that. So that's what I would say to that.
All right, wow, that's another awesome answer. Well, with that, we have a really interesting question coming your way, Todd. One of our users has asked, when are you predicting the MLOps will be adopted and used in large scale by organizations, and the usage is still in research as well as POC level? What do you have to say to
Yeah.
that?
I mean, so my prediction would be it will be widely adopted by 2009. No, I'm just kidding. I'm just. I think so. The right way to this is a great question. The right way to think about this is just like so. What happened? What happened with large scale distributed computing? First, we did stuff, and then stuff broke, and then we got angry about how often things broke, and then we sat down and thought about being a little bit more careful and more systematic. So when we ask ourselves, why didn't we do continuous integration and continuous delivery in 1995? Because we didn't feel like we had to, and we hadn't thought of it, and it wasn't a big deal, and we just kind of wrote some software and shipped it, and sometimes it worked and sometimes it didn't. And those were happy days, I guess. I'm not sure. I'm sure most of the audience was born after 1995. But that's my point, is that we used to do ridiculous things that now we would be terrified to do. Machine learning will be the same way. First, we will see people use machine learning. Then we will see people have very bad problems because they weren't careful about how they used machine learning. Then we will see MLOps start to be taken much more seriously. And so I wish we could, we're humans, so I wish we could skip the step where we learn our lesson, but I honestly don't think we will. I think we will do some things. I think those things will hurt us, and then I think we'll go about fixing it. So I think it's going to be a few years. But what I think is important for this audience is there's a great moment right now to really start building school tools and building familiarity and building understanding of these things so that you're ahead of that curve.
Okay, wow, another awesome answer. But now I really want to ask a very interesting question to you. I've got to know that you come from a philosophical background, and I just saw your presentation and I could see that you love predicting things. So now combining both of these two things together, where do you see the industry going in the next 5 years in terms of machine learning? Your predictions.
So I think that I think we're at a transition period now. Machine learning can and should be widely adopted, but broadly speaking, people don't trust it yet. And I think that's okay. I don't think I love technology. All of us are here because we love technology. We love change. We love new things. We love what computers can do for us. But I also think if we're here at a DevOps organization and a DevOps conference, we all know these things break all the time, and we are skeptical and we are not trustworthy. And I think we should be skeptical of machine learning. I think that we are going to see for the next several years increasingly big uses of machine learning and then increasing distrust of machine learning until we can build up that trust. And so I'm excited to see there's a bunch of my colleagues at Google and also at other organizations who are doing work to try to do ethical and reliable artificial intelligence. So ways that we can build models that do things that we understand, that we can rely on, whose provenance we know. We know these models are not sexist, they're not racist, they're not biased against people from particular parts of the world or particular parts of a country. We understand why they make certain decisions they make, and they work the way we want them to. We're not there yet. Most models can't do those things for us yet. But if they could, we would get faster adoption. So I'm hoping to see more and more infrastructure in reliable and trustworthy machine learning, not just because that's the right thing to do as humans. Like, we should not replicate our own biases in our computers. We should try to do better, but also because we'll get more advantage faster if we can all rely on these things. So I think we're in for a difficult 5 years, but if we get through it, we're going to see an enormous amount of machine learning in the future after that.
So when you talk about getting through this entire vision for the next 5, 10 years, as you just said, we as humans we do make mistakes, and the way we program the machines, they do exactly the way we want them to perform most of the times, right? Um, and as I just mentioned a few minutes back, that the machines, they do not differentiate or anybody in terms of the race or color and all those things. Uh, do you think that that part is an advantage when we think about the future of machine learning maybe 10, 20 years later? Because we are the people who program the machines the way they work, and if something goes wrong, ultimately we are at fault.
Yeah, so I think it could be an advantage. So right now we're at a stage where we are building models that are sometimes quite biased, and I will get in trouble if I cite too many examples, but many of you can search for examples of very biased machine learning algorithms. Where did that bias came from? It came from us, right? Like, as you say, like, it came from us. We are biased, and like, all of us grew up in an environment and have a set of biases built into us that now we express that the machines are learning from. And so right now we have a lot of bias that we're still struggling to remove. In the future, if we do a good job, we could have a much, much more fair future, but only if we're thoughtful about governance, if we're thoughtful about responsible AI, if we're thoughtful about the way that we do these things ethically. And so I'm excited for that future, but I guess what I'm saying, and maybe this is just my reliability engineering background, but there's plenty of ways for us to mess that all up and have terrible catastrophes. There's lots of ways for this to go wrong. There are some ways it could go right. So I hope that we're able to do better than we are, because I think humans are wonderful. I love us, but we are fundamentally biased people, and we're all struggling to overcome that all the time. And I think most of us would like to live in a fairer world where more people have more opportunity and more chances. But in order to do that, we have to get past where we are now. And so it's going to be an interesting time.
Absolutely. Well, Todd, such an interesting conversation with you. Thank you so much for inspiring
Thank
all
you.
of us today. I think this is one of the best sessions we had in the entire day. And as I just said, we saved the best for the last. This was truly the best session, I must say. I think all of us in the team would agree with that. Such an inspiring session with you, Todd. Thank you so much once again for being at the DevOps India Summit.
Thank you.
All right, Todd, I would love for you to please share your handles, if you can, with the audience, if you're still there, so that people can connect with you if they want to have any questions with you. For
Sure. Yeah,
you.
they're on the first slide, but I'm at TMU on Twitter, and on LinkedIn. I'm Todd Under. So feel free to connect, and if you have questions, I encourage people on Twitter to share links to this talk and make fun of me. I think that's a really good way to join in the community of people who are always laughing at my talks. So feel free to do that.
Well, I must say you have a great sense of humor, and I'm sure you will not mind if people do throw some
Not
funny
at
lines
all.
at you.
Not at all.
Well, that's superb. That's superb. All right, Todd, thank you so much once again for joining us. Hope to see you in person very, very soon at the next session of the DevOps India Summit. So, with that, ladies and gentlemen, we come to the end of the last keynote session for the day. Thank you so much for joining us. I'm sure all of you truly, truly enjoyed this session. It was such an invigorating session, and I must say, we all of us, I think none of us were bored even for a minute, right? It was such an interesting talk by Todd. And as he just said, he's available on LinkedIn, on Twitter. So please do connect with him. You can make fun of him, as he rightly said. He's given the permission to you. So please do that. And with that, we come to the end of this session. My name is Riya Kumar. This is DevOps India Summit 2022. Thank you so much for being with us. I really, really loved hosting this entire session with all of you. Thank you so much, and for making this conference such a big success. Thank you, everyone. Hope to see you in the next DevOps India Summit 2023 next year at this very month. Watch out for the updates in the website. We'll let you know when the dates will come out. And hopefully, this time, we're going to see you in person. Thank you so much once again for your time. This is the DevOps India Summit 2022, and I am Riya Kumar, your host for the day. Thank you.